Hi everyone, welcome to this lecture. So in this lecture, we will learn how we can process features with the help of perceptron, how we can associate weights with the features, and what are activation functions, why they are important to improve the performance of the neural network. Okay, let's start with the example. Suppose few candidates appear for interview in a company and company's output after the interview will be either selected or not selected. That is, if the candidate is selected, it will be assigned a value 1, and if it is not selected, it will be assigned a value 0. Okay, the company will classify the candidates based on some qualities of the candidates. So these are the 4 qualities of the candidates which are known as the features of the candidates. Based on these qualities, company will decide whether they will select the candidate or not select the candidate. So these feature or qualities are the qualification relevant to the job, experience, communication skill, and address of the candidate. Now, we call these qualities as a features. Let's call them as X1, X2, X3, and X4. Now, these 4 features are the qualities of a candidate which is appearing in an interview. Let's see how we can process these features with the help of perceptron and make decision about the candidate. Okay, now X1, X2, X3, X4, they are the features of the candidates or the qualities of the candidates, and we are processing these features through a perceptron. Here we are getting the output from the perceptron or this simple neural network. Here perceptron is performing addition on these features. Therefore, our output is X1 plus X2 plus X3 plus X4. Now let's assign weights to each feature based on the job requirements. So we have 4 features. Now it's time to assign the weights based upon the importance of the feature. So we see that the qualification relevant to the job is most important feature. Therefore, the weight assigned to this feature is of highest value, that is 1. Similarly, experience and communication skills are also considered as important feature. So their weights are 0.6 and 0.3 respectively. Similarly, if we see that the address of the candidate, it might not be a very good feature in order to get the job. Therefore, the weight assigned to this feature is very small, that is only 0.01. Now let assign these weights to the feature and then process them with the perceptron. So here we have assigned the weight to each feature, that is W1 to X1. Similarly, we assign W2 to X2, W3 to X3, and W4 to X4. Now this will become our new output equation based upon the weights. So here we are getting W1 X1 from this branch. Similarly, W2 X2, W3 X3, and W4 X4. So that will be our neural network or perceptron score, which will help us to decide about the candidate. Now, if we assign all X1, X2, X3, X4 is equals to 1, then their values depend upon the weights associated with them. Now, this is 1 and this is also 1. So X1 times W1, it will become 1 times 1. So this is W1 X1, this is W2 X2, that is here, and this is W3 X3, and this is W4 X4. If we add all these value, we will get 1.91. So this is our perceptron score or a neural network score. Now, based on this score, we have to assign a value or a label either 1 or 0, because 1 means the candidate is selected and 0 means the candidate is not selected. So how to transform this 1.91 into a decision? Now, for this, we need to model this output value of a perceptron or a simple neural network. Now, how to model this output? In order to model this output, we need an activation function. The reason is that this 1.91 is the output value of the perceptron for this particular candidate. If there is another candidate whose output will definitely be different from 1.91 based upon the weights associated with his qualities. Similarly, if we have many candidates, then the output will be different. That is, we might get a value of 0.81 at the output, 0.91 at the output, 1.1 at the output, maybe 2.7 at the output. So we will get the different values at the output. Then how to reach to the decision? So in that case, we need to model the output of this simple perceptron or a neural network. In order to model the output of a neural network and to make the decision, we need an activation function. So this is our activation function. Here we are using threshold-based activation function. This is the definition or the property of this threshold activation function. This threshold activation function will generate 1 if the output of neural network is greater than 1, and it will generate 0 if the output of a neural network is less than 1. So for this value, which is 1.91, this value is greater than 1. Therefore, the activation function will generate 1 and the candidate will be selected. So this is the first introduction of the activation function in neural network, and we see that activation function is used to model the output of a neural network. It ensures the consistent performance of a neural network. That is, the neural network score might be any, that is between 0 and to any highest value. In that case, in order to make a decision or in order to reach the decision, we need to model this output of a neural network. And for this purpose, we need an activation function. So activation function is important when we have to model the output of a neural network and when we have to ensure the consistency in the performance of a neural network. So this is the first introduction of activation function in neural network. We will discuss it more. There is a whole section on the activation function. So I hope you understood this lecture, that how we use activation function with neural network, how we process the features and weight with neural network or with simple perceptron. So I hope you understood this lecture. Thanks for listening, and I will see you in the next lecture.